Hey guys, today we're going to look at solving and graphing inequalities. So what you see in front of you for notes, there are 4 inequality symbols: less than, greater than, less than or equal to, and greater than or equal to. So they are here. Oops, let me switch colors. Less than, greater than, less than or equal to, and greater than or equal to. So some common phrases that you'll see that we use in everyday language that are associated with inequalities are: example 1, P is at least 25. And you should try to do these on your own a little bit and see how correct you are. P is at least 25 means P is greater than or equal to 25. G is no more than 8. That means G is less than or equal to 8. N is no less than 30. No less than means not less than, but greater than or equal to. N is greater than or equal to 30. And A is at most 15. A is less than or equal to 15. Always put your variable on the left side when you're writing these inequalities. So I should have the variable on the left, on the left, on the left, on the left. Okay, they're always read from the variable, from the point of view of like what could the variable be from left to right. We solve inequalities and we graph them just like we would equations. So if you look down below, example 5, you have solve for x. So we're going to add 212 to both sides. I have 2x is greater than or equal to 6. And then I divide both sides by 2. This tells me that x is some number greater than or equal to 3. And we show this is called a solution set, because there are infinitely many numbers that are greater than or equal to 3. So I go to 3 and I show that x could be equal to 3, meaning I color in my circle, or it could be any number larger than that, which is to the right of 3. And this is shading. This is not drawing a line. This is me shading the number line, showing you a picture of what numbers x could be. That's why we put x on the left. We're saying x could be greater than or equal to 3. Now, if I'll change colors. If there was no equal sign, if it just said x is greater than 3, then my number line would be an open circle and then shade to the right. Okay, so the blue goes with the blue, saying that x can't actually be 3, but it could be any number bigger than 3. And that includes decimals, so 3.01, 3.1, 3.159. Like, I'm just picking random decimals that are larger than 3. So that's why we can't start on 4, right? Because there are decimals between 3 and 4 that we would be skipping over. Okay, so take a look at the next one. Negative 5x plus 6 is greater than or equal to 26. This, I'm isolating x, so I'm going to subtract 6. I have negative 5x is greater than or equal to 20, and I'm going to divide both sides by negative 5. Now, we come to this rule, which you may or may not remember from last year, and the rule is when you're dividing or multiplying both sides by a negative number, you have to switch this inequality symbol. Okay? When dividing or multiplying by a negative number, switch inequality symbol. So this answer would be x is less than or equal to negative 4. And the reason why we do that is just a simple little show you why on the side here, is if you know two numbers have a relationship like 2 is less than 3, no matter what number you pick, as long as it's positive, if you multiply both numbers by by anything, it has to be the same number, then the left side will still be smaller than the right side. So if I multiply by 100, 200 is still going to be less than 300. But this doesn't hold true when you multiply by a negative. When you multiply by a negative, 2 is less than 3. If I multiply by negative 100, what happens is the relationship flips. Negative 200 is bigger than negative 300. And that's why we flip the inequality symbol whenever we multiply or divide by a negative. Okay, so going back to our example 6, x is less than or equal to negative 4 is either equal to negative 4, so I put a colored in circle, or less, meaning to the left. All right, so in the next little section, we're just doing a little exercise of looking at the inequality without solving. Okay, don't solve. Just looking at it, tell whether you would have to switch the inequality symbol. So you can pause the video and try this one on your own and see if you get them all correct. So in example 7, I would mentally say to myself, I am adding 3 to both sides, so no, I do not need to switch the inequality symbol. In example 8, I'm dividing by 2. So even though there's a negative here, I'm dividing both sides by 2. Again, I'm not doing the problem, I'm just showing you in my head what's going on. So no, I'm not switching the inequality symbol. In example 9, yes, I'm switching the inequality symbol because I'm dividing both sides by -3. And in example 10, yes, I'm switching the inequality symbol because I'm multiplying both sides by -4 to clear out that fraction. Okay, example 11 is showing you something really important that I mentioned before, which is you always want your x on the left side. Oops, I meant to do highlighter. Sorry. Well, I'm highlighting now. You want your x to be on the left side. So when you see an inequality written this way, take this and move it over to the left. 4x minus 2. And now as I read backwards, I'm actually looking at is greater than -14. Right? Because I'm reading this backwards and I'm at the open mouth, like you guys learned the alligator. Okay? So now I solve once I rewrite it. So I add 2 to both sides. I have 4x is greater than -12, and I'm going to divide both sides by 4. Do I switch the inequality symbol? No, because I'm dividing by 4. So x is greater than -3. So that means x is a number at -3, but not equal to it. So open circle or greater or to the right. All right, we're going to stop there for today. You guys have some homework on this. It should be pretty simple and straightforward. I will see you all tomorrow. Thanks.